This is the final lesson of the testing chapter, and I'm going to show you how we can do automated testing inside of the CI/CD pipelines by running our unit tests, our integration tests, and our functional tests inside of GitHub Actions. Let's jump into the code, and let me show you a couple of things we have to do before we can actually run our tests inside of GitHub Actions. This is the GitHub Actions workflow file that we added to our solution at the start of the course. The one small change I made inside of the workflow file is introducing an additional flag in the .NET test command. I added verbosity normal so that we get some useful logs inside of GitHub Actions when we are running our tests. And this is all you need to run functional tests and integration tests inside of GitHub Actions. You probably already knew that unit tests would work fine, but so will integration and functional tests, even though they are using Docker to run Postgres and WireMock for mocking requests to the GitHub API. All of this functions inside of GitHub Actions because it has support for Docker. This is also going to work in Azure DevOps because it also supports Docker. So this is how we can get the highest level of confidence with our deployments by first running our entire test suite before executing the publish step. Now let's go into the code because we will have to make a couple of adjustments for this to work correctly. We'll have to make a couple of small adjustments to the DevHabit web application factory inside of the integration test project and inside of the functional test project. The reason everything was working correctly on my local machine is because I had any configuration values present inside of my settings files and inside of application secrets. One of the things that we will be missing when we move into running these tests inside of a CI/CD pipeline is the encryption key value, which could be pulled from my application secrets because I introduced it in the lesson when we created the encryption service. However, for testing purposes, the best solution will probably be setting the configuration value inside of the web application factory. I can create a random key that's 32 bytes long, convert that into a base64 string, and set that as the respective configuration value. And this is going to work just fine for integration testing purposes, but also for functional testing. So let me go ahead and make the update here as well. So that's the first thing we will need to fix. The second problem we will probably run into is issues with Quartz and background jobs and our application stopping after the test complete. So for this reason, I'm going to introduce this line of code that is going to set the null logger as the current logger for Quartz. This is the part that's problematic, and we don't even need logging from Quartz inside of our tests, so this is a trade-off that I can live with. And now that I've made these changes, I can go ahead and run all of my tests again just to make sure that they are all still passing. And after a couple of moments, all my tests light up with green, and you can see that all of the tests are passing. One more thing we can do at this point is check our code coverage. Because I have access to ReSharper, I'm going to run the cover all tests from solution command, and we're going to examine the code coverage report. After a few moments, I'm going to get the code coverage report from ReSharper, and we can see that our code coverage is 87% on the solution level, which I consider to be pretty decent. Inside of the source folder, our code coverage is 83%, which is also not too bad. And then you can see a breakdown based on the top level namespaces, and we can see what the code coverage is in the DevHabit API project. Now, if I drop down the controllers folder, we can see the code coverage for the individual controllers. And you can see that the least covered is the user's controller, where the getUserById endpoint is completely uncovered, and so is the update profile endpoint. So these would be a couple of integration tests that I could add to the solution. The most covered is the habit tags controller, which is kind of to be expected because it only has 2 endpoints and both of them are pretty simple. When it comes to the services folder, you can see that we get pretty good coverage inside of the important services. These are the link service, the user context, the token provider, the GitHub Access Token service, but be aware that this only tells you that the specific lines of code have executed within a unit test, an integration test, or a functional test. It doesn't really tell you if the code that you have ran is working as expected. But nonetheless, code coverage can be a useful tool together with a proper testing suite like the one that we have developed in our previous lessons. Now let's actually see how to run our tests inside of the CI/CD pipeline. I'm going to close down the unit test coverage report, and I'm going to commit the changes that I just introduced and push them to my repository. And if I jump into my repository on GitHub and open up the specific action that's running my CI/CD pipeline, we can go ahead and take a look at the individual steps. So you can see that the build step is running, And if this step succeeds, I'm going to proceed to run the testing step, where we're going to see if our tests are actually able to run inside of our CI/CD pipeline that's running using GitHub Actions. After a few moments, you can see that the build step has completed and our tests are going to kick off. And this is going to take some time to complete because we have integration tests and functional tests. And after about 1 minute, all of the integration tests and the functional tests are going to complete. Our build pipeline is green, so everything completed successfully, and I think I even managed to perform a stress test on the GitHub Actions runner because I generated more than 13,000 log statements inside of my test suite. If you take a look at the logs, you can actually see the logs from ASP.NET Core. Here are the logs from the EF Core provider representing the queries that we are sending to our Postgres database, which is running inside of a Docker container using the test containers library. You can also see the logs from ASP.NET Core itself, representing the endpoints that we are calling inside of our APIs. For example, here's the call to the refresh token endpoint, here's the call to the register endpoint. So you can see that our tests are simply working out of the box, and we're able to run integration testing and functional testing inside of our CI/CD pipeline in GitHub Actions. And with this, I'm also going to wrap up this lesson. And I think that we are ready to move on to our next chapter in this course, which is going to be about documenting REST APIs. Welcome to the next chapter in the Pragmatic REST APIs course, where I'm going to show you how you can document your REST API. This is a very important topic when it comes to developing any kind of API, because at the end of the day, you build an API for your clients, and your clients need to be able to know how to use your API. Hypermedia, which is something that we discussed in a previous chapter, is only part of that story. Proper API documentation can help your clients understand how to use your API, what are the available API endpoints, what do your request and response schemas look like, what are the media types that you support, and much more than that. So here's what we're going to cover as part of this chapter. We will begin with a discussion about the OpenAPI specification. We already mentioned it a couple of times in the past. I showed you what the OpenAPI specification looks like when we were discussing using it to generate an HTTP client, and we're also going to briefly cover it as part of this chapter. We're also going to talk about the OpenAPI support in .NET. There have been some changes here in the last couple of .NET versions, and I think this is important to highlight. I'll show you how to add the Swagger UI to your application and how to implement rich API documentation that's going to function nicely with Swagger. Because our API also supports versioning using media types, we have to properly document our API versions. This is also another topic that we are going to cover as part of this chapter. Our API endpoints also require the user to be authenticated, so documenting authentication is another important thing that you have to think about. Lastly, I'm going to show you an alternative user interface to the Swagger UI, just as a little bonus to wrap up this chapter, and also because I think it can be a valuable addition to your toolchain if you are building a public-facing REST API and properly presenting the documentation is important for you. I think we are ready to move on to our next lesson, where I'm going to talk about the built-in support that we have in .NET for working with the OpenAPI specification. If the name OpenAPI isn't familiar to you, I'm sure you've heard about Swagger. Swagger was a built-in tool for building the OpenAPI specification, and it also came with a user interface, and it was an integral part of ASP.NET Core applications for many years. However, starting from .NET 9, Swagger is no longer part of the default toolchain in .NET web applications. Instead, there is a Microsoft OpenAPI library which aims to replace Swagger. Now, how successful it is at replacing it is up for debate, and let's see what conclusion we come to by the end of this lesson. This is the latest version of the OpenAPI specification at the time of recording this video. But what is the OpenAPI specification? It's a programming language agnostic interface description for HTTP APIs. And the essence of the OpenAPI specification is that it allows both humans and computers to discover and understand the capabilities of a service or a REST API without requiring access to the source code, additional documentation, or inspection of network traffic. So we can conclude that the OpenAPI specification is a standard that we can use for documenting our REST API. Then we have Swagger, which you're probably very familiar with if you've ever built an ASP.NET Core API in the past few years. It's a set of tools that build on top of the OpenAPI specification, and they essentially allow you to implement and use this specification. The most popular tool is the Swagger user interface, which was built into ASP.NET Core applications all the way up to .NET 9. Now in .NET 9 things changed. Microsoft decided to release their own OpenAPI SDK for .NET applications, and this is what we are using starting from .NET 9 to generate OpenAPI JSON documents inside our applications. It's also something that I demonstrated in some of our previous lessons. Now let's go into our code and see how we are actually using this library. If you open up the program file of our DevHabit API project, you will see that we have a call to app map OpenAPI. And what this does is it exposes a minimal API endpoint that's going to resolve the OpenAPI document that is associated with the current application. The other component that we need to make this work is inside of our add API services method. And here you will find a call to builder services add OpenAPI. So this introduces the required services into the service collection. Now another thing that might not be so obvious is inside of the call to add controllers. Let me go into the definition of this method, and inside of it you will see a call to add controllers core. Now here you'll find a call to add API Explorer, and this is what's actually going to scan the controllers that we add to our application and make it available for generating the OpenAPI document. Now if I start the application and I navigate to localhost 5001 OpenAPI version 1 JSON, we're going to see our OpenAPI specification. You can see which version of the OpenAPI spec we're supporting. This is 3.0.1, and below you'll find the definitions for all of our API endpoints, the response types including the status codes, the media types that we are supporting such as custom media types with versioning, or the vendor specific media type that returns our hypermedia links. Near the end of this document, you'll see the definitions for the actual DTOs. So it contains the definitions for our public-facing contracts, which represent our request and response DTOs. And this is pretty much all that we have available with the current tooling. That is why in the next lesson I'm going to introduce the Swagger library to help us document our REST API. The first thing I want to do is introduce the user interface so that we can observe how our OpenAPI specification can be translated into a user interface that we can use for documenting and even testing our REST API. But also I want to highlight some drawbacks of the current OpenAPI support that we have in .NET.